Okay, on to the next unit. This is a sheet you're going to be using throughout the unit. Tear it off. Let me explain what it's talking about. Everybody knows what square root is. For example, square root of 49 is 7 because what times what's 49? Got to be the same factor twice. It's 7, so that's why it's 7. It also could be negative 7 because that's 49, but I don't have the positive or negative. Okay, now cube root. I'm going to pick a random number. The cube root of 25 is 5. Why? Because now it's a cube root, so it's what used as a factor 3 times would give you 125. It's not 1, it's not 2, 3. How about 5? Well, that's what it says it's equal to because 5 times 5 times 5 is 125, so it's equal to 5. Okay, the fourth root. What times what times what times what is, I'll pick 625. Now, why is the answer 5? Because if I take 5 times 5 times 5 times 5, that's 625. And also a negative 5 times a negative 5 times a negative 5 is also 625. So this could be the positive or the negative. These could be the positive or negative, but not these. Okay? Here's why. So 25 is 5. So if I go 5 times 5 times 5, that's 125. If I take negative 5 times negative 5 times negative 5, that's negative 125. So the negatives are going to have their own root. Okay? Okay, so find all real square roots of each number. Okay? Well, this isn't hard. Okay? I'm going to put a radical, and if it's a square root, I'm going to put a little 2 there. Now, this is how in this unit you want to evaluate your radicals. You're going to go 2 second, but instead of x squared, you're going to go caret, okay? 2 second caret 625. So that's 25. Now, since it's an even root, it can be a positive or a negative, so you need to put that. 25 times 25 is 625. So is negative 25 times negative 25. Okay, next one, decimal, I do the same thing. So I go 2, you need to get in the habit in this unit of 2 second caret 0.0025. Okay, 0.05, now that could be positive or negative. Now, fraction, that's fine. Put it over the fraction. Now, if it's an even root, if you have a negative under the root, here's what I want you to do. Okay, I want you to I want you to try it on a calculator first. 2 second caret negative 4 ABC 9. You got a domain error. I don't want you poking the eye out in this assignment here. You got a domain error. That means no real roots. Okay. When I poke the eye out, that's called an imaginary root. Okay. I stands for imaginary. That's why they use it. Okay. So no real roots. So if you get that negative, punch it in a calculator. Okay. Because there's no real number times itself that equals a negative. Okay. Right here. So 2 second caret 25 ABC 144, it's 5 12s, which makes sense because the square root of 25 is 5, the square root of 144 is 12. Now again, that could be the positive or the negative, so that's square roots. Always a positive, negative, unless of course you get the domain error because you can't take the even root of a negative number. Okay, don't do the I in this, okay? Now you're finding all cubed roots of each number. I wrote that wrong. That's supposed to be a negative 512. Now we're doing cubed roots. So we put a radical, but instead of a 2, we put a 3. Okay? That means what times what times what is negative 512. Now some of you look at that, you're like, oh, it's a negative, no real numbers. No, because it's not a square root. So I go 3 second caret negative 512. I got negative 8. I did not get a domain error. So it's negative 8, and it's only the negative 8. Odd roots don't have a positive and a negative, okay? It's just the one answer that we get. Now you're like, how is that? Well, because if I take negative 8 times negative 8 times negative 8, I'm at negative 512, so I'm good. Now, if you have a negative under a root, if the root's even, okay, it's going to be a no real roots. But if the root's odd, you're actually going to get a legitimate answer, a real number answer. And another thing on evens, okay, maybe something you want to write on your radical sheets, okay. Evens, positive, negative. The odds, only 1, okay. And the evens cannot have a negative inside. The odds can have a negative inside now, if it's an odd root, okay. So if you're in doubt, use your calculator. So 0.343, so I put a 3 over it. So I go 3, here's what you don't do, 3 second x squared, that's wrong. Because that takes 3 times the square root. Well, I'm not doing a square root. I want a cubed root. The only way to get it is 3 second caret 0.343. Okay, 0.7. Not positive negative though, because it's odd. Okay, just the 1. Okay. So 3, so I go 3 second caret, okay, negative 8, ABC 729, got negative 2/9, okay, because a cubed root of negative 8 is negative 2. Why is that? Because negative 2 times negative 2 times negative 2 is negative 8, and then 9 times 9 times 9 is 729, okay. This is wrong right here, okay. So the cubed root, I want you to put negative 27, okay. So it's only going to be one answer because it's an odd root, okay. So 3 second caret negative 27, okay, I got negative 3. So the odds are, you're not going to get a no real root answer with the odd if it's a cubed root or a 5th root or whatever, a 7th root, okay. There has to be one. Okay, the even roots, if you have a negative, you're going to get the no real roots. Now, so the evens are positive, negative. The odds are just the 1. It could be positive or negative, but just the 1. Okay, now let's go find some 4th roots. Okay, 4th root of 81. Okay, so that's asking what times what times what times what is 81. Let's figure it out. 4 second caret 81. 3. Now we're back to an even root, so we need to apply the positive negative, okay? Maybe just write that right away. If you're doing an even root, put your positive negative right away. If it's an odd root, don't put a sign. You'll just get the one answer. Okay, now let's apply this. That's going to be a domain error because we're taking the even root of a negative. Odd roots with negative works, evens do not. Domain error, okay? So no real roots, which is possible when you're doing an even. 4 is an even number. Okay. 4 second caret 0.001. So by the way, get the positive negative sign down. Okay, 0.2. And the 4th root here. Okay. Positive negative down. So 4 second caret. Here, do them one by one if you want. If you don't want to use the ABC key. The 4th root of 625 is 5. Okay. 4th root of 1,296 is 6. Okay. Okay. So if you're in doubt, use your calculator. Okay, if it says domain error, you just put no real roots. Don't worry about poking the I out because I is not a real root. That's an imaginary root. Okay, now find the 2 real solutions of the equation. Now, you're like, I really have to write all this crap with the x squared and the GCFT. No, you don't. Because all you have is x squared and the constant. Well, when you just have the variable and its power and the constant, you're just going to apply a root. And the root would be a square root. That cancels the second power. Then I apply a square root over the 49. So it's an even root, so it could be the positive or the negative, and the square root of 49 2 second caret. It's 7. I'm just showing people for effect on a calculator. Okay, positive or negative 7. Okay, x to the 4th. Now, yes, you have x to the 4th, but you don't have the x third, x squared, x crap. Okay, and you're like, doesn't that have to have 4 answers? No, actually it doesn't, because when it's just a variable exponent and a constant, you apply the root. The most you're going to get is 2. Okay, so now I apply a root, but it's got to be a 4th root to cancel out the 4th power. Okay, even root could be the positive or the negative. So I go 4 second caret 625, just like that. I got 5. You're like, there must be 4 answers. That's just 2 of them. No, there doesn't. If you have x to the 4th and the constant, there can be 2. With the variable with power and the constant, there can be 2 at the most. Now, if it's a cube root, I'm not even going to have 2. I'd have just the 1. Okay. Now, 2. So again, positive or negative. 2 second caret 0.04, and you get 0.2. Okay. 4 over both of them. So it could be the positive or negative. Now you can do one at a time, or you can do the whole fraction, but the 4th root of 16 is 2. 4th root of 625 is 5. Okay. So no, do they always have 4 answers with x to the 4th? No, if there's like an x third and an x squared and an x, yeah, there would be 4, but just the x 4th and the constant, just a variable with its power and a constant, there's only 2 at the most. Okay, now the last part of this. Now you're going to simplify the radical with a variable. Now, if your radical doesn't have an index, get used to putting a 2 there automatically. It's automatically a 2. So now what you're going to do is break this up. This is what I like to do. Square root of 16, and then a square root of x to the 8th, at least for today's assignment. Square root of 16 is 4. I mean, these are your 4. Could be positive or negative 4. Now, here's how you do your variables. You don't just, you don't take the square root of 8. Okay, x to the 8 means x times x times x times x times x times x times x. Now we're taking a square root. So you're allowed to break up your square roots into multiple square roots, and since it's a 2, we're going to put it over 2 of them at a time. Okay? 2 at a time. Okay? Didn't write enough x's. Because square root, x times x is x squared, right? A square root and x squared cancel, giving us x, 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 x. So I get positive or negative 4, and then x to the 4th power. Okay, next one. Now, break it up. So we have the cubed root of a to the 6th, the cubed root of b to the 9th. Now, a times a times a times a times a times a, b times 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 b. Now you're going to put the radical over 3 of them at a time. So 3 and a 3. Because a times a times a is a to the 3rd, but having a cubed root cancels it and gives me just a. Okay? And likewise with the b. So that'd be b, b, b. So I have a to the 2nd now because there's 2 a's that popped out. Don't have a coefficient like I did on this problem. So, and then that would be b to the 3rd. Here's a news flash. With the variable and exponent, to find the power on the variable and the root, you could just divide the inner exponent by the radical degree. Just saying. You cannot divide the coefficient by the radical degree, okay? Because 16 divided by 2 is 8. That's not what we got. But the exponent, because 16 is not an exponent, but the exponent can be divided by the radical degree. If that's confusing to you, just do it this way. So the 4th root of x to the 8th. So x times 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 x. Okay, so it's a radical 4 x to the 8, radical 4 y to the 12. Okay, because that's the two factors you have. Okay, so we're going to do 4 of them at a time. Now 4, okay, because it's a fourth root. Fourth root, x to the fourth becomes x, okay? So I got x to the second. Oh yeah, some of you are like, do we have to put the plus minus? Only if there's a coefficient number, okay? This one didn't have, these didn't have it, so I'm not doing it. Okay, and y to the 12th. Okay, 4 of them, okay? So 4, 4, 4. So all those become just a y, okay? That's y to the 3rd. You can divide if it's an exponent, you can just divide it by the inner. 8 divided by 2 is 4, so it'll be x second. 12 divided by 4 is 3. Now here's what I don't want to see. The 81's not an exponent, okay? And the square root of x to the 4th. You don't divide 81 by 2. 81 is not an exponent, okay? It's a coefficient base. So you do this like you normally do, square root of 81. You can either use calculator or your sheet. 81's 9. 2 second caret 81, that's 9. So that could be a positive or a negative 9. Now the root, okay, exponent root, you can do it the old way. Group it. So that's the only group you got, so it'd just be x. Or you could put x to the first if you want. Usually if it's the first, I'd just write x. And 2 more. Okay, 2 factors, a to the 12th, b to the 15th. Now, I'm not going to write all those. If it's a variable and an exponent, you can just divide the exponent by the radical degree. So 12 divided by 3 is 4. Okay? 15 divided by 3 is 5. You've seen how that works, or that's no coincidence. What you cannot do is divide 256 by 4. Don't do that. Put your radical 4, 256. Find that. So look in your fourth roots. 256 is there. It's 4. It's even, so it could be a positive or a negative. But when you get to your variables, you can just divide 12 by 4. It's 3. 16 by 4 is 4. Okay? But you cannot divide the big coefficient by the radical degree. Only a variable's exponent can be divided by that. Okay? 256 ain't an exponent.